Hi everybody. Now we are going to see about the design and model analysis of composite propeller shaft. Here I have done my project in SK engineering. The main aim of our project is to replace metallic propeller shaft of automotives by composite propeller shaft. The requirement of this modification is to increase the efficiency of power transmission by reducing the weight of the propeller shaft. We intend to analyze the project through SolidWorks simulation. The purpose of the project is to reduce the amount of rotating masses in the drive train. A lightweight drive shaft will be constructed. In racing, every hundredth of a second counts. The race car pitted in an unending battle against the clock is modified to sequence every bit of horsepower out of it. The track car is full of racing equipment but currently has a steel drive shaft. The new drive shaft should take less energy to spin. Therefore, more of the energy produced by the engine can be transferred to the wheels. Failure of the propeller shaft. The major cause of the failure of propeller shaft are vibrations. Propeller shafts are usually caused by incorrect vehicle trim height, powertrain mounting problems, failed or failing U-joints, improperly phased or twisted propeller shaft, improper propeller shaft working angles, drive axle problems. Incorrect vehicle trim. Vehicles that are heavily loaded, towing a trailer, or have modified suspension systems can cause the trim height to be incorrect, resulting in improper propeller shaft angles. This will cause the universal joint working angles, which can cause improper U-joint acceleration and deceleration cancellation to take place. This can result in a second order propeller shaft speed related vibration. If the vehicle has been raised with a lift kit or lowered, the vibration may be totally correctable. If the powertrain is allowed to move excessively, the working angles of the U-joints can be affected. This causes improper U-joint acceleration and deceleration cancellation to take place. This can result in the second order propeller shaft speed related vibration. As the propeller shaft rotates, the universal joints actually speed up and slow down twice per revolution. This is not a constant velocity device. A U-joint which is failing can cause these speed fluctuations to be felt or heard with the driver of the vehicle. Failing U-joints. Improperly phased or twisted propeller shaft. A twisted or improperly manufactured propeller shaft can have U-joints which are out of phase. This causes improper U-joint acceleration and deceleration cancellation to take place. This results in a second order propeller shaft speed related vibration. Steps involved in the project: selection of cross section and materials, 3D modeling, analysis of composite drive shaft, comparison of results. Now the selection criteria: HM carbon or epoxy material with fiber volume of 60% is selected for composite drive shaft. Here are the values, properties, symbols and units. And here comes the steel shaft diagram, the working diagram, composite shaft diagram as same of the steel shaft diagram. Here comes the design of the shaft. Here comes the outer diameter, inner diameter, length of the shaft, thickness of the shaft, denoted by the symbols D0, DI, L, T. The values are represented in the table. The calculation of the steel shaft. Formula M is equal to rho AL. The values are substituted and the value of the mass of the steel shaft is found to be 10.23 kg. And torque values are substituted and torque is found to be 2.4 into 10 to the power 11 Newton per mm. Now the calculation of composite shaft, the same as formula of the steel shaft. Boundary conditions: both ends are fixed and a torque applied at the center of the shaft. Model analysis of composite drive shaft. Results: the deformation form of the composite shaft at first mode. Here comes the answers diagram. The displacement rate of composite shaft in x directions. The values are represented by the different colors. The displacement rate of the composite shaft in y direction as first mode. Displacement at z direction as first mode. The total displacement counter of composite shaft at first mode. Comparison of results. The frequency values are noted for steel shaft and composite drive shaft. The values are tabulated. The main advantages of the composite shaft are they have high specific modulus strength and reduced weight. Due to weight reduction, fuel consumption will be reduced, the main aim of the project. They have high damping capacity, hence they produce less vibration and noise. They have corrosion resistance, greater torque capacity than steel or aluminum shaft. Lower rotating weight transmits more of available power. Conclusion. The final part. A one-piece composite drive shaft is considered to be replaced as a steel drive shaft. Its design procedure is studied, and along with the finite element analysis, some important parameters are obtained. The composite drive shaft, made up of high modulus, carbon, epoxy, multilayered composites, are being designed. The replacement of composite materials has resulted in considerable amount of weight reduction, about 76% when compared to conventional steel shaft. Also, the results reveal that orientation of fibers has great influence on the dynamic characteristics of the composite shaft. Thank you.